Hi guys, so the first thing I want to do is go over investigation number 1. So let's flip back to that, and hopefully you were able to find a pattern here. So first thing, if you're looking for what's cosine of what is equal to sine of 20, the answer should have been 70. So just to verify that, I'm looking through the table. So sine of 20, if I go to sine of 20, that would be this left-hand column. Go down to 20, we get 0.3420. If you go over to 70, you should see that cosine, so the middle column of 70 equals 0.3420. So I found that those were equal. Then I could look and see for part B, I got 57 degrees for this one. So again, if you compare sine of 33, so sine of 33 would be this first column on the left, and then go to 57 degrees. So 57 degrees in the middle, you should see you get the same answer, 0.5446. And then sine of 45, you should have gotten 45 for cosine. So if you look at 45, that one was easy because they were in the same row, different columns. Then we have sine 55, that's going to equal cosine of 35. So if you scan sine of 55, you get 0.81. And then if you go down to 35 in the middle, you get the same thing, 0.8192. And then this pattern continues, so you should have gotten 30 and 5. So the pattern hopefully you see is between the two angle measures is that these always have to add up to 90. So 20 plus 70 gives me 90, 33 plus 57, 45 plus 45, 85 plus 5, 60 plus 30, and 55 plus 35 always had to add up to 90. So for sine and cosine to be equal, it has to be that you're taking sine and cosine of complementary angles, because remember, complementary means adds to 90 degrees. So let's actually just add that down at the bottom here. So the conclusion that you should have gotten from this first investigation is that sine and cosine of complementary angles are equal. So basically these numbers from the chart, they came from some triangle, and then these are the ratios. So when we say sine of 36, the ratio between that triangle's opposite over hypotenuse sides came to be 0.5878. So it was some fraction that was reduced. So just to refresh your complementary, you might want to add that definition down here. So complementary angles means angles that add to 90. That add to 90 degrees. It's really two angles that add to 90 degrees. So let me say two angles that add to 90 degrees. So this is only going to be true, sine and cosine are only going to be equal if the two angles that we're taking sine and cosine of are complementary. So let's look at the other investigations and see how this applies to triangles. So you were able to see it with just numbers. Let's go to investigation number 2. So this investigation, first thing is they're giving you this right triangle. They tell you the angle measures and they tell you the sides. They don't tell you side AC, so let's go ahead and find side AC. So if I wanted to find side AC, think about what you have. You have a right triangle and you have a missing side. So you should have used Pythagorean theorem for this. So x squared plus 15 squared equals 40 squared. And then you're gonna square these, so you end up, so square them, subtract them, you end up with x squared equals 1375. And we'll square root both sides, so we end up with x equals 37.081. So I'm just gonna round that to 37, and I'll just make it easier for this. So x equals 37. So now when I go to do the sine and cosine, we know right away that the 40 is always going to be the hypotenuse, so you might as well just put the hypotenuse there, that won't change. But if I'm trying to find sine of A, so we're thinking back to SOHCAHTOA here. So sine is opposite over hypotenuse. So sine of A is what I'm looking at first. So looking at A, the opposite of A will be 15, and then the adjacent is going to be this 37. So opposite would be 15 over the hypotenuse, which is 40. And while I'm using angle A, let's go ahead and do this one, cosine. So cosine is going to be cos, so adjacent over hypotenuse. So adjacent is going to be 37 over the hypotenuse of 40. And then let's switch our labels, because now the other two ratios here you're looking for are sine and cosine of angle B. So starting at B, now the opposite is this side, and the adjacent is the 15. The hypotenuse stays the same. So sine of B is going to be opposite over hypotenuse because it's the slow part. So opposite is going to be 37 over the hypotenuse, which is 40. And then cosine is adjacent over hypotenuse, so 15 over 40. So hopefully you see a pattern here that these two are equal. So sine of B is equal to cosine of A, and sine of A is equal to cosine of B. So again, that's a conclusion we can write, that the sine of B is equal to cosine of A, but notice what's true about angle A and angle B. So if you look at angle A and angle B, hopefully you notice that those must add up to 90 degrees, which is what happened before. 22 plus 68 will give me 90 degrees. So let's write that down. So the first conclusion is that the measure of angle A plus the measure of angle B equals 90 degrees, because 22 plus 68 equals 90 degrees. So this means, so this tells us that angle A is complementary to angle B. And then the second conclusion is that the sine of A is equal to the cosine of B, and vice versa. The sine of B is equal to the cosine of A. So that's something. So that's pretty much the same conclusion as what we had in the investigation number 1. Instead of looking at the table to come up with sine and cosine values, we looked at a triangle, and then we came up with the ratio of themselves. But again, we still saw that these angles are complementary. So those two angles were complementary, as well as sine and cosine of the complementary angles being equal. So let's look at the third investigation. This third investigation is basically the same idea but without numbers. So this is basically like generalizing what we just saw in the first two investigations. So first thing it tells us is that we're given that these angles, so the alpha and beta, they're just Greek symbols, nothing special, just saying, okay, angle A is going to be represented by alpha, angle B is going to be represented by beta. And these are the measurements of complementary angles. So that's telling us that angle A and angle B have to add up to 90. They're complementary. So that's something that we should make note of down here. So right away we can say angle A, again, is complementary to angle B, because that's given to us, because alpha plus the beta, which are representing those angles, equals 90 degrees. So the measurements of those angles have to add up to 90. So then it wants us to go ahead and come up with the trig ratios. So sine of alpha, so sine of alpha means I'm going to start here. The opposite, here's the hypotenuse. Hypotenuse will always be across from that right angle. This is the adjacent side. So if we're thinking about sine, so that's the so in the SOHCAHTOA. So that's this. It's opposite, which is going to be side A, over the hypotenuse, which is C. if I look at cosine of that same angle, cosine is going to be the adjacent, which is B, over the hypotenuse, which is C. Then we'll switch it and we'll go do the sine and cosine of angle B, which is beta representing that angle. So now I'm going opposite this, so adjacent becomes the opposite, and the opposite becomes the adjacent. So opposite, so if we're doing sine, it's going to be opposite over hypotenuse, so it's going to be B over C. And cosine is going to be adjacent, which is A over the hypotenuse, which is C. So again, you see that same pattern that the sine and cosine of the complementary angles are equal again. And this basically shows you that this is always going to be the case because we don't have any numbers here. So this pattern, whatever numbers we plug in for A, B, and C will always hold true as long as those other angles are complementary, which the only time that these angles wouldn't be complementary is if you don't have a right triangle. And when we talk about these trig ratios, we're always talking about them in right triangles. So we'll always have this first statement, that angle A and angle B, or the two acute angles, will always be complementary. The reason why they would always be complementary is because if you think about it, in a triangle, all three angles add up to 180. So if this plus this equals 180, well, subtract off the right angle, which is 90 degrees. So you have 180 minus the 90. That means that you have 90 degrees left, because you got rid of this, you have 90 degrees left split between these two angles. So that tells you these two angles have to add up to the 90 degrees. So these acute angles will always be complementary in a right triangle, which means that this conclusion will always hold true. Conclusion number 2, that sine of alpha, in this case, equals cosine of that other acute angle, and sine of beta will always equal cosine of alpha. So basically, the sine and cosine of complementary angles will always be equal. So that's a theorem, and here's basically, we just looked at 3 different ways to kind of show it. The other idea behind this, as long as you have this right triangle, well, if you remember when I labeled, I started with angle A and I had opposite and adjacent, and then when I went to angle B, I crossed off those two things and they switched. So what happens is, why this is true, because if you think about sine and cosine, the ratios, the only difference between sine and cosine of an angle is one has opposite and one has adjacent. They both use the same hypotenuse. Hypotenuse always stays the same. And when you switch the angles, so when I have angle A, the opposite of angle A is really the adjacent of angle B. So that's why this is going to be true, because the opposite for sine of angle A is going to be the adjacent of the opposite angle, or angle B, and when you use cosine. Same thing with this one. So when I was finding sine of B, I was using the opposite, which is the adjacent of angle A. So since they switch, that's why it's sine and cosine of complementary angles have to be equal. So that's the idea behind why this is working. So this, what we're talking about, this whole idea is known as the complements of cosine and sine. And it's this rule right here, that sine of theta is equal to cosine of 90 minus theta. This notation right here, theta and 90 degrees minus theta, that means that you're talking about two complementary angles. So this means that you have complementary angles. The reason why those are complementary, so again, same thing goes with this, is because if you add those, they add to 90. So let me show you. So if I take theta and I add 90 minus theta to it, go ahead and add them. What happens is these cancel, you're left with 90 degrees, which is why this and this are complementary, because they add to 90. So this is the notation. So this is like the complements, sine and cosine complements theorem, or the complements rule. So this is called sine and cosine complements. So we call them complements because they're equal for complementary angles. So let me just add that here. Sine and cosine are equal of complementary angles. Which is why one is sine and the other one is cosine for complementary to each other, or equal for complementary angles. So now let's look at, like, so now hopefully you understand why this is true. Let's look at what would you use this for. So if you see something like this, so this is kind of what you guys had to do with the table, except for you don't really need the table anymore. So you're trying to find, okay, well, cosine of 32 would equal sine of what? So basically what you know is that these two have to add to 90 degrees. If they're equal, that means that the angles add to 90. So you just set up an equation, set them equal to 90, and solve it. So subtract the 32 from both sides. So we get theta equals 58. And if you want to change theta to x, you can, if it makes it easier to solve. But remember, theta is that symbol, or that variable that we use for these trig functions. So let's look at this next one. Same thing. So if cosine and sine are equal, well, that means that those angles must be complementary. So that means they must add to 90. So theta plus 20 degrees must equal 90 degrees. So combine like terms. So this is like 2 theta. Again, change them to x if you'd like. Plus 20 equals 90. So subtract 20 from both sides. You get 2 theta equals 70. Divide by 2, you get theta equals 35. So I'm going to have you guys pause the video and go ahead and do these examples on your own. So these, go ahead and do right now. Take about 5 minutes to do that, and when you're done, replay the video so that we can go over them. So work on these for about 5 minutes. Okay, so hopefully you had enough time to complete most of these. Maybe you didn't get all of them, but that's okay. So let's quickly just go through these answers. So again, I'm just going to add these up, set them equal to 90. So when you do this, you get 2 theta plus 38 equals 90. Subtract 38, so you get 2 theta equals 52. Divide by 2, so you get theta equals 26. Next one, if this is true, if cosine equals sine, then these angles must be complementary. So add them up, set it equal to 90. So again, you get 2 theta equals 120. When you add the 30 to both sides, divide by 2, you get theta equals 60. Next one, same idea. If sine and cosine are equal, the angles must be complementary. Add them up, set it equal to 90. So we have 4 theta when we combine like terms, subtract the 20, so 4 theta equals 70. Divide everything by 4 and you get theta equals 17.5. And then this last one here, so again, add them up, theta over 3 plus 10 plus theta equals 90. Since you have a fraction, I would get rid of the denominator. You can get rid of the denominator by multiplying every part by 3. That's probably the easiest way to do that. So those cancel, so you have theta plus 30 plus 3 theta equals 270. And then you combine your like terms, so we have 4 theta plus 30 equals 270. Subtract 30, so 4 theta equals 240. Divide, so we get theta equals 60. So that's it for those. And then let's look at just 2 more examples of some other types of problems that you could see dealing with this whole concept. So the next example, or the next two examples are actually ones from sample problems from the state. So these are questions that could show up on like an exam, something similar to this on a Regents exam. So for example 3, this is basically just asking you to explain why is this complements theorem or rule, why is it true? So think about the picture here. If we have, I think the easiest way to think about it is, first of all, if we have this triangle, so let's say I call this A, B, and C. We know, so let's call this x, and then this measure will be the 90 minus x. We know, first of all, that A and B are going to be complementary. So we know that these angles, so let's say, first of all, so we know x and 90 minus x are complementary because if we actually add them up, x plus 90 minus x, cancel out the x's, it equals 90 degrees. So that's the first part. So we know that this only is going to work when the angles are complementary. The second part is that basically those trig ratios. So since these two angles are complementary, this is only going to work in right triangles. So if we're looking at our right triangle, I have, let's start with angle A. So if I label the sides for angle A, so this is going to be the opposite. The hypotenuse will always be across from C. And then the adjacent will be this side right here. So if I look at this side here, or this first situation, I know that sine of x is going to equal opposite over hypotenuse. So then when I look at the cosine of 90 minus x, so let's switch this now. So if I'm looking at this, this becomes the opposite. This becomes the adjacent. And the hypotenuse stays the same. So sine of x is equal to opposite over hypotenuse, and cosine of 90 minus x, which is angle B, is equal to adjacent over hypotenuse. And since the opposite and adjacent of x and 90 minus x are the same thing, that tells me that these are equal to each other. So when we look at this, opposite and adjacent, so the opposite of x is right here, and the adjacent of 90 minus x is right here. Since these are the same side, these two things have to be equal. So these are equal. So this means sine of x equals cosine of 90 minus x. So basically, let me write this up. So let's say since the opposite side of x is the adjacent side of 90 minus x. I'm going to put that in parentheses so you know it goes together. So since the opposite side of x is the adjacent of 90 minus x, we know that we know that they are equal, that the opposite side of x is equal to the adjacent side of 90 minus x. We know that I'm going to write it like this. Opposite of x equals adjacent of 90 minus x, and sine of x must equal cosine of 90 minus x. So that's the first version of this. The second version is basically the same exact reason, but we start with cosine of x, and we show that it's equal to sine of 90 minus x. So basically I could have said over here, start with x and say that the adjacent is equal to the opposite of 90 minus x. So I'm just going to write it like this. Using this same reasoning, we also know that cosine of x equals sine of 90 minus x. So bottom line, the whole idea is that the adjacent of one of the angles is the opposite of the other. That's why it works, because then what happens is the two ratios end up being the same. Alright, the last example we're going to look at then is much easier to explain. You're just trying to show that, or you're just trying to find the value of x. So when we look at this example, it says in right triangle ABC we have a right angle at C. So let's go ahead and sketch this picture out. So A, B, and C, right angles at C. We know that the sine of A is equal to this, and the cosine of B is equal to 4x minus 0.7. Determine and state the value of x. So first thing is, we know that angle A and angle B must be complementary. So I'm going to go ahead and start with that. So we know, because it does say to explain, so we know angle A is complementary to angle B because in a triangle, all angles add to 180 degrees, and if angle C is a right angle, angle C, or the measure of angle C, equals 90, and 180 degrees minus 90 degrees is 90 degrees. So measure of angle A plus the measure of angle B has to add up to the 90 degrees. So basically, since this is 90 degrees, all three angles add up to 180. Take away the 90, you're left with 90 degrees to split between angle A and angle B. So since angle A is complementary to angle B, we now know that the sine of one has to equal the cosine of the other. So since, because now we're using the complements rule, so since angle A is complementary to angle B, we know that sine of A must equal cosine of B, and vice versa. Sine of B equals cosine of A because of the complements. I chose to write sine of A and cosine of B because of what was given to me up there. So now I can just plug into this. So instead of saying sine of A, I can plug in 2x plus 0.1, and instead of saying cosine of B, I can plug in 4x minus 0.7, and now we just solve it. So it's just an equation we solve. So subtract 2x from both sides, and then I'm going to go ahead and add this 0.7. So I get 0.8 equals 2x. Divide by 2, and we get 0.4 equals x. So that's it. So basically, it's just using the theorem a different way. So instead of saying that we add the two angles, they gave us what sine and cosine equaled. So we set them equal and solve for x that way.